Find the greatest common factor of the following. Our example we will have here. For our next problem, let us find the greatest common monomial factor of 8x squared y cubed and 16x y squared. First, let us find the factors of 8 and 16. The factors of 8 we have here 1 multiplied by 8, and we also have 2 multiplied by 4. And for 16 we have 1 multiplied by 16, and then we have 2 multiplied by 8 and 4 multiplied by 4. And then we will find here the common factors. We have here 1 and 1, and we also have 2 and 2, and then 4 and 4, and 8 and 8. But the greatest common factor is the number 8. So the GCF now of 8 and 16 is 8. Let us now find the greatest common factor of x squared and x. Okay, so x, this is understood that the exponent is 1. Now the greatest common factor will be the one with the lowest exponent. So x raised to 1, or x here, is our greatest common factor. How about for y raised to the power of 3 and y raised to the power of 2? So the GCF here will be the one with the lowest exponent, and that is y squared. And now our GCF here will be, so the GCF of 8x squared y cubed and 16x y squared, their GCF now will be 8 and x and y squared. So therefore 8x y squared is our final answer. For next example, we are going to find the greatest common factor, or GCF, of 20a raised to the 4th, b raised to 5, c raised to 6, and another term we have here 25 a cubed, b raised to the 2, and c. And then we have a third term, 35 a squared, b raised to the 4th, and c raised to the 3. So we have 3 terms here. Let us first find the GCF of all the constants. We have 20, 25, and 35. For 20, so for 20, our factors here for 20 will be, we have 1 and 20, 2 and 10, and then we have 4 and 5. How about for 25? Let us find the factors for 25. So the factors of 25, we have 1 and 25, and then we have also 5 and 5. And let us find the factors of 35. So the factors of 35. The factors of 35, we have 1 and 35, and then we have 5 and 7. Now, what are the common factors between the 3? So we have here 1. 1 is common on all the 3 terms, or on all the 3 constants. And we have also 5. So 5 is common among the 3. But the greatest common factor here is 5. So the GCF of 20, 25, and 35 is 5. Okay, let's write it here. GCF. GCF of 20, 25, and 35 is 5. Okay. Let us now find for the GCF of A, B, and C. or the GCF of the variables of the three terms. Okay, let's first have here A4, and then we have also A3 and A2. The GCF of the three will be the one with the lowest exponent, and their GCF here is a raised to 2. How about for B? We have here b raised to 5, b raised to 2, and b raised to 4. The GCF here will be the one with the lowest exponent, and that is b raised to the power of 2. And for C, we have C6, C, and we have c raised to the power of 3. The GCF here would be the one with the lowest exponent, and we have here c. Therefore, the GCF now of our given here, so the GCF of our given problem, their GCF now would be equal to, we have here 5, and then we have a squared b squared c. And this is now our answer for this problem. Factor the given problems using the greatest common monomial factor. Our given here, we have 36 m raised to 9, n raised to 5, and p raised to 4, plus we have 12 m raised to 5, n raised to 4, and then we have p raised to the power of 3. So we need to factor this binomial. Okay, let us start by finding the greatest common factor of each monomial. When we speak of monomial, each term, so we have here two terms, this is called a binomial. Okay, but we are going to find, or we are going to factor every term, so we will factor monomial. Let's start with the constants. We have here two constants. We have 36 and 12. So what will be the greatest common factor of 36 and 12? List down first the factors of each number. The factors of 36, we have 1, and 36 we have 3 and 12, and we also have 4 and 9, and then 6 and 6. And for 12 we have 1 and 12. We also have 2 and 6, 3 and 4. Okay, and then let's find out the common factors. The common factors are 1. We also have 3. Yes, 3. And then we have 4. How about 6? Yes, we have 6. And then we have 12. But the greatest common factor of them all is 12. So our GCF here is 36. Okay, we can now put here the greatest common monomial factor, or the GCF. We can now put 12. Okay, so we will find the other common monomial factors. Let us start with the m variable. So for m variable, we have here m9 and m5. The greatest common factor here will be the one with the lowest exponent. 5 is the lowest among the two. Our greatest common factor will be m5. And for n, we have n raised to 5, and n raised to 4. Our greatest common factor here, the one with the lowest exponent, will be n raised to 4. And then we have p. We have p raised to 4 and p raised to 3. Our greatest common factor here would be the one with the lowest exponent, and that is p3. Okay, so we can continue now our GCF here. This will now be 12, and then we have m raised to 5, and then n raised to 4, and p raised to 3. So our GCF here is 12, m raised to 5, n raised to 4, and p raised to 3. We may now proceed to the next step, and this is dividing each term by the GCF. Let's start with the first term. We have 36 m raised to 9, n raised to 5, and p raised to 4. We will divide each term. So we will divide this by the GCF. Again, our GCF is 12 m raised to 5, n raised to 4, and p raised to 3. And we have here our second term. Do not forget the addition sign. And our second term is 12m raised to 5. We have n raised to 4 and p raised to 3. And then we will divide this again by the GCF. Our GCF here is 12m raised to 5, n raised to 4, and p raised to 3. So the GCF now, or the answer for this division, 36 divided by 12, okay, cancel that out. This will now be 1. And 36 divided by 12, that will be 3. Okay. M raised to 5, we can cancel this out. This will now be 1. And we will subtract 5 here. 9 minus 5, this will be, we can write here 4. And then n, okay, this is smaller, so we can cancel this out because this will be equal to 1. And 5 here will be 5 minus 4, this will be equal to 1. And we can cancel this out, that is equal to 1. 4 minus 3, this will be 1. Okay. And looking at this second term, we can see that the numerator is the same as the denominator, so we can just cancel this out since this is also equal to 1. Okay. What remains on the first term will be, we have 3. And then since the denominator is all 1, we will have no denominator here. So we have 3, and then for m, the remaining exponent is 4. And then for n, we have the exponent of 1. No need to write it here. And for p, we also have an exponent of 1. And then plus, okay, 1 divided by 1 is 1. Multiply it by the GCF. Okay, our GCF here is 12 m5 n4 p3, and then multiply this by this factor. Okay, 3 m raised to 4 and p plus 1. Therefore, the factors of our given problem, this is equal to 12 m raised to 5 n raised to 4 p3, and it is multiplied by the quantity 3m raised to 4 and p plus 1, and this is our final answer. Let's solve another problem. We have here 45 a raised to the power 5, and then we have b raised to 2, c raised to 10, and d we have here raised to 3, minus 75 a raised to 9, b raised to 10, and then we have here c raised to 5 and d. We will factor this out. So first, we are going to get the greatest common monomial factor. Let's start with the constants, 45 and 75. Okay, we are going to list the factors of 45. We have here 1 and 45, and then 5 and 9, and 3 and 15. For 75, the factors of 75, we have 1 and 75, and 5 and 15. So the common factors here, we have 1, and then we also have 5 and 15. But the greatest common factor among the three is 15. So our GCF here, part of our GCF now will be equal to 15. Let's find the remaining factors. Let us start with a. So we have here a raised to 5, and then we also have a raised to 9. So the greatest common factor between a raised to 5 and a raised to 9 is the one with the lowest exponent, and that is a raised to 5. How about for b? We have here b raised to 2 and b raised to 10. And the greatest common factor will be b raised to 2. How about for c? For c, we have c raised to 10 and c raised to 5. And it will be c raised to 5. And for d, we have here d raised to 3 and d. Of course, the lowest exponent will be d. Okay, so we can now complete our greatest common factor, and this will be a raised to 5, b raised to 2, c raised to 5, and d. Okay, so what are we going to do with our greatest common factor? This will now be one of the factors of our given binomial. So what we need to do is that we need to divide each term by the GCF. Okay, let us start with the first term. Our first term, we have 45 a raised to 5, b raised to 2, c raised to 10, and d raised to 3. And we are going to divide this. Okay, divide this by our GCF. Again, our GCF is 15, a raised to 5, and b raised to 2, c raised to 5, and d. And then, let's divide. Dividing, we have here 45 divided by 15. So 15 is common between 45 and 15. So 15 divided by 15, this will be equal to 1. 45 divided by 15 is 3. A raised to 5 over a raised to 5, we can cancel the 2 since this will now be equal to 1. B squared divided by b squared, this is also equal to 1. C raised to 10 all over c raised to 5, we can cancel this out. This will now be equal to 1, and then we will subtract the exponent. 10 minus 5, this will be equal to 5. So the remaining c here will be c raised to 5. And for d raised to 3, we can cancel this out. This will now be 1, and this will be 3 minus 1. The exponent now of d is 2. Okay. So what will be left here will be 3 raised to 1. We have 3. And then a raised to 1. Okay, this will now be 1. And what's left here will be c raised to 5. And we also have d raised to 2. Okay, let's put here the addition sign and the second term. We will also have here the addition sign, or rather that is the minus sign. And then we will put here the minus sign and the minus sign. Let's divide now the second term. We have 75, a raised to 9, b raised to 10, c raised to 5, and we have d. All over, okay, again, our greatest common monomial factor, we have 15, a raised to 5, b raised to 2, c raised to 5, and d. Okay, and then dividing. So dividing, we will now have 75 and 15. 15 is common between them, so divide 15 divided by 15 divided by 15 is 1. 5. Okay, so 75 divided by 15 is 5. And then a raised to 9 all over a raised to 5, this will be 1, and this will be 9 minus 5, this is 4. b raised to 10. So this will now be 1, and 10 minus 2 is 8. C raised to 5 all over C raised to 5, this will be equal to 1, and D all over D is 1. So what will be left for the second term now will be 5 divided by 1, that is 5. And we have no denominators left, okay, since everything now is equal to 1. And then we have here A. The exponent left for A is positive 4. And we have for B, the exponent left is positive 8. C and D, they are both 1. So therefore, 3C raised to 5, D raised to 2, minus, okay. And since we have here one of the factors, we can now put the complete factor of our given problem. And this will now be, we are now going to multiply. So multiply the GCF, 15, A raised to 5, B raised to 2, C raised to 5, multiplied by D, and multiply this by 3C raised to 5, D squared, minus 5, A raised to the 4th, B raised to the 8th. So therefore, this is now our final answer for our given problem.